Hello, myself Dr. A.N. Basugade, Professor and Head Department of Statistics, Gopal Krishna Gokhale College, Kolhapur. Today we are dealing with the unit number 1, which is multiple linear regression, and that too a part 3. Now in part 2 we have discussed about the certain steps of derivation of plane of regression of x1 on x2 and x3. Also, we have defined the correlation matrix as given by delta, that is 1. First row is 1 because R11 is 1, R12, R13. Second row will be R12, actually R21, but it is same as the R12, and R22 is 1, R23. Third row is R31, but it is same as R13, R23 and 1. Now, the cofactor of one element of delta can be written as, you have to delete for this one, you have to delete the first column and first row. This multiplication 1 into 1 is 1 minus R23 square we have written here. Similarly, we can obtain the cofactors of 1/2 and 1/3 element of delta as delta 12 equal to minus of R12 minus R13 R23, and R13 equal to R23 R12 minus R13. So these are the three expressions we have got. Just multiply by minus to this first expression, we will get minus of delta 11 equal to, changing the sign of these, so that will be R23 square minus 1. And here also I will take a minus sign inside the bracket. It will be R13 R23 minus R12 as delta 1. Now I'll substitute these values, all these three values, delta 11, delta 12 and delta 13, in the expressions of B12.3 and B13.2, that is expression number 7 and 6 of the derivation. So finally we are getting B12.3 equal to minus of sigma 1 upon sigma 2 delta 12 by delta 11, and B13.2 equal to minus of sigma 1 upon sigma 3 into delta 13 by delta 11. Thus, the equation of plane of regression becomes x1 equal to, by beta, from equation beta will substitute B12.3 and B13.2. We are getting this expression as minus of sigma 1 upon sigma 2 delta 12 by delta 11 x2, and minus of B13.2 will be sigma 1 upon sigma 3 into delta 13 by delta 11 x3. I'll take all these terms to the left hand side, so this will be plus plus plus, and that will be equal to 0. Now from all these expressions I'll take sigma 1 upon delta 11 common. Here those terms are not there, just reverse way will multiply, so therefore delta 1 upon sigma 1, delta 11 upon sigma 1 into x1 is the first expression. This and this we have taken outside, and therefore delta 1 2 by sigma 2 into x2, delta 1 2 by sigma 2 is remained, and into x2 again this value and this value we have taken it out, therefore sigma 1 3 by sigma 3 into x3, that term remain in the bracket. I will take this to the right hand side, only bracketed term remains, so therefore I'll substitute the values. Okay, so that will give the expression. Thus the equation of plane of regression of x1 on x2 and x3 is given by, I'll substitute the small x1 small x2 small x3 in terms of capital X1 capital X2 and capital X3. So this bracket will becomes delta 11 by sigma 1. This will be capital X1 minus x1 bar, I have written here. This term remains as it is. Small x2 is capital X2 minus x2 bar, and small x3 is capital X3 minus x3 bar, that is equal to 0. So this is the final expression of plane of regression of x1 on x2 and x3. Now there are certain properties of error, or we can say residual, and they are fixed. First property is fixed, second is fixed, and third one is the numbers are fixed. So the first property is the sum of product of a variable and a residual becomes 0 if subscript of a variable occurs among the secondary subscript of a residual. Means this is a variable, this is the subscript 2, and it occurs in the secondary subscript of a residual, then this sum of product becomes 0. Similarly, this is the variable subscript and that occurs in the secondary subscript, then product is 0. That we have to prove. Consider the normal equations B first and second for estimating the values of B12.3 and B13.2. Already we have seen in derivation of this expression of uh, plane of regression of x1 on x2 and x3. So these are the two expression normally equations I have written here. Just I will multiply this square bracket will be x1.23. This is again 1.23, so this x2 into 1 to x1.23, and this is x3 into x1.23. So this will be product will be 0, and hence the property. In general, if there are p variables, then summation xi into x1.23 I p I will occur in secondary subscript, then this product will be equal to 0 for all I equal to 1 to p. Now the second property says that the sum of product of any two residuals in which all the secondary subscripts of first residual occurs among the secondary subscripts of the second residual is unaltered or unchanged if we omit any one or all the secondary subscripts of the first residual. Consider proof of this. Consider the residual in case of two variables, that is x1 and x2, and it is given by this expression x1.2 equal to x1 minus b1 to x2, and x1.23 is for three variables, this is for two variables. Now we'll take the sum of product. The sum of product of x1.2 and x1.23 is this one, but this expression for this is I have substituted here, and this x1.23. Now I'll multiply inside the bracket and taking separate sum, so it will be summation x1 into x1.23 minus b12 is constant, I'll take it out, and this product and sum. Now this secondary this subscript of a variable occurs in the secondary subscript, therefore this product will be 0. This vanishes, we are remained only with this. So I have deleted the subscript 2 from this one, and therefore this is the property. So this is for two variables. Now we will prove it for three variables also. Three variables means x1.23 and x1.23. This is for residual for three variables. This is also residual for three variables. So that will be x1.23 square can be written as in this fashion. Now this residual is written in this square bracket, and this x1.23 is as it is we have kept. Again I will multiply by this x1.23 inside the bracket and taking separate sums. So this will be x1 into x1.23 minus b12.3 summation x2 into x1.23 and b13.2 summation x3 into x1.23. Now this 3 is occur in secondary subscript, therefore this is 0 by property 1. 2 is here in secondary subscript, therefore by property 1 this also 0. So this I have written in here. Only we are remained with this one x1 into x1.2. So this is x1.23. The secondary subscripts occurs in the secondary subscript, therefore you can eliminate one or both the subscripts of the first, so that we have deleted all the secondary subscripts. So this is the property second. I will go for the third property. The sum of product of two residual is 0 if all primary as well as secondary subscript of one residual occurs among the secondary subscript of the other, then it will be 0. That product will be 0. So proof of this is, consider the sum of product of x1.2 and x3.12. That means this primary and secondary will occur in the secondary subscript, then sum of product will be 0. That we have to prove. So consider this one summation of this. So this will be this value I have written as x1 minus b12 x2 and x3.12 is as it is. Again I will multiply inside and taking separate sums, so that will be this expression. Again this will occur in the secondary subscript, therefore this vanishes. Okay, 1 is occurring in the secondary substitute, therefore this vanishes by property 1. So by property 1, this and this will be 0. So this 0 minus b1 to 0. So whole thing becomes 0. That is the property 3. Hence the proof. Now the last part of this unit number 1 is variance of residual. Let x1 dot 23 be the residual of x1 on x2 and x3, that is x1 dot 23 equal to x1 minus its estimated value, that is the error or residual. So this is the formula will be x1 dot 23 equal to x1 minus b12 dot 3 x2 minus b13 dot 2 x3. Now I will take the sum on both the sides and divide by n. Then what we are getting, summation of this divide by n, 1 upon n, this complete bracket. I will take inside the 1 upon n. So 1 upon x summation x1 by n, b12 dot 3 summation x2 by n, b13 dot 2, because these are the constant, summation x3 by n. So this will be x1 bar, this will be x2 bar, this will be x3 bar. Therefore x1 bar minus b12 dot 3 x2 bar, b13 dot 2 x3 bar. But already x1 bar, x2 bar, x3 bar in derivation of equation we have proved that they are 0. So first term is 0, second is 0, third is 0, the whole thing becomes 0. So mean of this residual is also 0. This is the mean x1 dot 23 bar. So that bar will be 0. Now we'll consider the variance of that residual, that is sigma 1 dot 23 square. What is the formula? That is 1 upon n, residual is x1 dot 23 minus its mean whole square. That is the definition of variance. Using that definition we have written this one, but already this x1 dot 23 in previous part we have seen proved it as a 0. Therefore you are remained with x1 dot 23 square. So that is square. So square means x1 dot 23 into x1 dot 23. So again by property 2 will eliminate this 23. So it will be x1 into x1 dot 23. So this will be 1 upon n as it is, and this 1 upon n is kept as it is. X1 into formula or the expression for this one I have written here. Now I'll take the summation sign and I'll take the product of this, multiply inside the bracket, taking separate sum and dividing by n. So this is summation x1 square divided by n, b12 dot 3 x1 x2 divided by n, and b13 dot 2 summation x1 x3 divided by n. So this is the expression. Now already x1 bar is 0, therefore it is summation x1 minus x1 bar square, but x1 bar is 0, therefore it is only x1 square by n. That will give you the sigma 1 square b12 dot 3. This expression already in derivation we have seen r12 into sigma 1 sigma 2. This is again b12 dot b13 dot 2, and for this one r13 sigma 1 sigma 3. That is the expression here. And also we know that b12.3 as expression we have proved, and b13.2 equal to this one. Now substituting in this expression, sigma 1.23 equal to this value as remains as it is. This b12.3 equal to with minus sign, this minus minus will become plus, sigma 1 by sigma 2 delta 1 2 by delta 1 1 into r12 sigma 1 sigma 2 as it is. Again I will substitute the value from b13.2 from this expression. This minus and this minus becomes plus, and you are remained with sigma 1 by sigma 3 delta 1 3 by delta 1 1 into r13 sigma 1 sigma 3. This is the expression. Now I'll take sigma 1 square divided by delta 1 1 as a common factor. So if I take this as a common factor, then what you are getting here, there will not be any delta 1 1, therefore just I will multiply by delta 1 1. This sigma 1 and this sigma 1 square is taken out, this sigma 1 1 is taken out, and this sigma 2 will get cancelled. You are remained with only r12 and delta 12, r12 delta 1. Similarly here also sigma 1 square is taken out, sigma 3 will get cancelled. You are remain with only r13 delta 13. So that is there. So this complete expression will give you delta, this sigma 1 square as it is, and delta 1 1. So this is the expression of variance of a residual, that is delta into sigma 1 square by delta 1 1. So these are the things we have studied in the unit number 1, that is the multiple linear regression. Thank you. That finishes your unit number 1. Thank you. Thank you very much.